In this lesson, we're going to finish off the topic of integration for the moment, and we're going to look at the integration of some brackets. Now, we'll come back to further integration in the third unit of the course, so this won't be the last that you see of integration, and certainly not because you should be studying all the time for your exams. So, a task to start with, I want you to integrate x plus 3 with respect to x. So if you just pause the video for a few seconds, put your working down for that, and then come back and we'll have a look at what we're going to do next. Okay, welcome back. So hopefully you've got x squared over 2 plus 3x, and I've not got limits here, so I've got an indefinite integral, so I need my constant of integration here. Now your next task, I want you to expand x plus 3 all squared all over 2. So again, pause the video, go away and do that, come back. Okay, welcome back folks. So I've got this time x squared plus 6x plus 9 all over 2. And expressing that as a sum of terms, I've got x squared over 2 plus 6x over 2, which you can see is 3x plus 9 over 2. And hopefully you can notice that these sort of match. Obviously we've got the constant of integration here, and we've actually got a value here, but the rest of it does match. Now, if I look back at the original question, I gave you the integral of x plus 3 with respect to x. I could have expressed that as the integral of x plus 3 all to the power 1 with respect to x. So you can see that those are the same, those are equal. What if this time though, I let u equal x plus 3? So my integration would change. I would actually have the integral of u to the power 1 with respect to u. And when I integrate that, I get u squared over 2 plus c. And I can put back in, instead of u, I can put in x plus 3. And you can see that my integral here is x plus 3 all squared over 2 plus c. So hopefully you can see the connection here. You can see that what I've got here from this integration, I've got my bracket was raised to the power 1, and it's now raised to the power 2, and I've divided by that new power of 2, plus my constant of integration. So hopefully you can see the connection here as to why I asked you to expand that in the first instance, and you can see that that's what you would have got. Okay, we'll have a look at another example similar to that. I'll run through this for you. But if you want to pause the video and go away and do it yourself, that's absolutely fine. So I want to integrate x plus 3 all squared with respect to x. You can see that's not currently in an integrable form as we know it, so I'm going to expand it, x squared plus 6x plus 9. And integrating will give me x cubed over 3 plus 6x squared over 2 plus 9x plus c. And simplifying will give me x cubed over 3 plus 3x squared plus 9x plus c. I now want you to expand x plus 3 all cubed over 3. That will give me x cubed plus 9x squared plus 27x plus 27 all over 3. And expressing as a sum of terms, I get something very similar to what I already had when I integrated. Obviously this was my original question. This time I'm going to let u equal x plus 3 again. So I've actually got the integral of u squared with respect to u. Now if I just did u squared, that would give me u cubed over 3 plus c. And putting x plus 3 back in for u, I get x plus 3 all cubed over 3 plus c, which once again, hopefully you can see that's what I asked you to expand in the first place. So you can see why all of this works at the moment. Okay, so let's have a look at an example. Okay, we've got the integral of x plus 6 all to the power 4, and we want to integrate with respect to x. So my bracket is raised to the power 4 at the moment, so that means when I integrate it's going to be raised to the power 5, and I'm dividing by 5, and I need to add on my constant of integration. And that there is my final answer. So just now would be a good time to pause the video, take down the example in your notes, and go and try the assigned exercise for today.